Hello students, welcome to Physics with Ashwini. In this session, we are moving one step ahead in motion in a plane chapter. So far we have understood the basics of projectile motion, right? Like how a particle is projected and how its motion can be resolved along horizontal and vertical directions. Now in this video, we are going to focus on one of the most important aspects, that is the trajectory of a particle. We'll see the trajectory equation, and along with that we will also discuss an important case, projection from certain height, which is very commonly asked in your exams. And to make your preparation stronger, as in every class we do, we will solve some important previous year questions based on these concepts. So stay focused because this part is very important both conceptually and also from an exam point of view. So are you all ready? So let's begin our session. What is trajectory? It is simply the path followed by the particle. So this is the path followed by the particle. And when you see trajectory equation, the important point that you have to remember, it should not include any terms of time. The equation must not have any time in it. The time quantity has to be eliminated in trajectory equation. Have you understood now what is trajectory? It is simply the path followed by the particle. Yesterday we have seen parabolic path. So what is that parabolic path? It's actually trajectory. Okay. Even the important thing, students, actually the equation of trajectory will help us to understand like why the particle is taking a parabolic path. Yesterday we have seen, right, when a particle is projected at certain angle from the ground, it follows a parabolic path. Why only parabolic path? Why not circular path? The answer for that question will be understood from equation of trajectory. But as this is a crash course and this is only for PYQ's discussion, I'm not explaining everything in detail here. As of now we'll just focus on PYQs, but later I'll just make a video and I will make you understand how this equation of trajectory explains the parabolic path. Okay, so now we'll see the equations of trajectory. There are two equations. Number 1, y is equals to x tan theta minus gx square by 2 u square cos square theta. What is theta? Angle of projection. What is this x? Distance traveled in x-axis. U is the initial velocity and y is the distance traveled along y-axis. They all stands for same meaning like what we have discussed in the previous class. Another equation of trajectory, x tan theta whole of 1 minus x by r. What is this r? This is a range of a particle. So two formulas. First formula is not having range. Second formula is in terms of range. So take half minute time, memorize both the equations, both the formulas. Y is equals to x tan theta minus g x square by 2 u square cos square theta, and y is equals to x tan theta of 1 minus x by r. And what is this trajectory? It is simply the path taken by the particle. Now we'll see one previous year question related to this. A projectile is fired from the surface of the earth just give me a second. Okay, got it. And what is the velocity of the projectile? It is 5 meter per second. And angle of projection is theta with the horizontal. There is another projectile fired from another planet with a velocity of 3 meter per second. That means there are two projectiles. One is projected from Earth, the other is projected from some another planet. Let us consider Jupiter, whatever it is, some another planet. And their velocities are different. Second projectile was also projected with the same angle. That means this is also projected with theta. It follows a trajectory which is identical with the trajectory of the projectile fired from the earth. This is a key point in the question. Read this statement. The trajectory is identical. That means the distance traveled along x and along y is same for both the projectiles. The value of acceleration due to gravity on the planet is. So we have to find the acceleration due to gravity on the planet. What shall we do? Let us understand this clearly. Let this be Earth. Let this be some unknown planet. We don't know what was that. Okay. What is the given data here? On Earth planet, the projectile initial velocity is 5 meter per second, whereas from the planet it is 3 meter per second. Angle of projections are same. What is the value of g on Earth? It is 9.8, right? For simplicity, you can consider 10. And they are asking what is g on the planet. So we'll do one thing. Let us take this as g1 and g2. And this is u1 and u2. And what did they say? Y value on the earth and on the planet, they are equal. X values are also equal. So let us take the trajectory equation. Y is equals to x tan theta minus g x square by 2 u square cos square theta. Can I consider second formula here? No, because range is not given, right? Now, x and y values are same for both the projectiles, right? So it's the same equation for the projectile from another planet also. So we'll do one thing. We'll apply it for first projectile, also second projectile. What will you get? X tan theta minus g1 x square by 2 u1 square cos theta. This is for the first particle, right? I'm not writing x1 here. Why? Because x values are same for both the projectiles and y values are also same. So we are equating y of first projectile with the y of second projectile because they are equal. Similarly, if you write the equation of trajectory for second particle, what will you get? X tan theta minus g2 x square by 2 u2 square cos theta. I'm not writing theta 1, theta 2. It is same for both the projectiles. Now what gets cancelled here? Simplify the expression. X tan theta cancel. Minus minus cancel. What is left now? g1 x square by 2 u1 square cos theta is equals to g2 x square by 2 u2 square cos theta. What else gets cancelled here? X square cos theta 2 2 cancel. So now what we are left with is g1 by u1 square and here g2 by u2 square. Just substitute the data. We want g2. So what will you get? G1, which is 10, into u2 square. What is u2 value? U2 is 3, so 3 square is 9. By u1 square, what is u1? It is 5, so 5 square is 25. So how much will you get? 5 twos, 5 fives. So you got 18 upon 5. So how much will you get? 5 threes 15 and 5 6 30. So it is 3.6 meter per second square. We took g value as 10. So you got 3.6. If you take 9.8, it is slightly less than 3.6. Because in the question they said take g value as 9.8. So if you take 9.8, slightly less than 3.6. That means what is our option? Option A is the answer. Is there any need to do this much lengthy of solution, or directly we can solve it? See, understand the question very carefully. Theta is same, y values is same, x value is same. What is changing here? Only initial velocity and g. So take only that expression directly. This is different, right? So we can directly take g1 by u1 square is equals to g2 by u2 square. Like this also you can simplify. Okay. I hope you have understood this trajectory and how to do the problems, right? Now we'll move on to the next topic, projection from certain height. So this is the diagram. I want you to observe it carefully. This is the ground, horizontal. So at certain height from the ground, projectile is taken and it was projected with initial velocity u meter per second. Now, if you see the diagram, it's pretty clear that there is initial velocity along x-axis. But do you find any initial velocity along y-axis? No, right? So I can say here initial velocity along x is u only, but initial velocity along y-axis is 0 meter per second. Is this point clear, everyone? Now it was following this path and finally it is falling onto the ground. Now what is this maximum distance traveled by the projectile? Horizontal distance? Nothing but range r. Clear? And how much time it will take? Let it be t. Have you all understood the diagram? Now for suppose randomly, if I select any point here, let this point be A. The particle was moving like this in this path. Will it be u only here or will it be v? This is after some time, right? So it will become final velocity. So what about vx? This is vx. And what about this? This is vi. Let this angle be alpha. That means after some time, velocity will not remain same because it was falling due to gravity. So the velocity is v now. So as usual, velocity is a vector and this is a 2D motion. As discussed in the previous classes, we have to resolve it into x components and y components, vx and vy. Now what is this vx? How do we find? Take the x direction. Initial velocity is u. Along x acceleration is 0. So how will you find the final velocity? Apply the formula v is equals to u plus at. So what will you get? V is equals to u only because acceleration is 0. Similarly, in y direction, what is initial velocity? 0. And what is acceleration in y direction? It is due to gravity, right? Now, what is the final velocity? V is equals to u plus at. So, that is equals to minus gt. This is your Vy minus gt. This is your Vx, which is u only. Did you recollect anything? Like the projectile at certain angle from the ground. Yesterday's concept. I have told you an important point. Along the x direction, there is no change in velocity. It remains u cos theta, u cos theta, u cos theta. Do you recollect? It's the same thing here also, right? At initial point, along x, velocity is u. And at some point a, along x, again the velocity was coming out to be u. So along x, there won't be change in velocity because along x, acceleration is 0. Got my point? Now, how do you find the total velocity now? You have to do the square root of x component square plus y component square. Okay. Now, there are certain important formulas that you have to remember. After seeing this part, like what we have discussed now, velocity in x, velocity in y, and I said initial velocity along y is 0. So, this point, does it hit something in your brain? Don't you consider it like the case of a freely falling body? In the case of freely falling body also, what is the initial velocity? Initial velocity is 0 and acceleration is minus g. Yes or no? Yes, right? So you can consider this projectile from some height similar to freely falling body. If you do this assumption, it's very easy for you. And what is the time of fall in freely falling body? It is under root 2h by g, right? So it's the same here also. Time of fall is under root 2h by g. Even for projectile from some height, time of fall is same. This is important point. You have a previous year question based on this concept. Time of fall will be same for a freely falling body, also for a projectile from some height. What is the range here? Range is nothing but horizontal distance, right? What is the formula for distance traveled by a body? It is nothing but speed into time. What is the speed here? Nothing but initial speed u. And what is the time? It is 2h by g. So what is the range now? U into square root of 2h by g. You may get a doubt, ma'am. Why did you take u? Because for range, It's the maximum distance traveled by the body from initial point to final point, again when it falls back onto the ground, right? And I told you yesterday, here velocities will remain the same. Along x it will be u only, along y with the change in direction it remains the same. Here along y velocity was 0, so here also what will be the velocity? 0. So you have only one velocity, so speed into 2h by g. Got my point? If you have actually not required, this is not required, but for those who confuse, I just added this point. Okay, the projectile was traveling with speed u, and what is the time taken to touch the ground? 2h by g. So distance is speed into time. So this is the value of r. Remember these two formulas? Pretty easy, right? Now, velocity after some time. So just now we have seen what was velocity along x, it was u. What was velocity along y, it was minus gt. Now what is velocity after some time? V net, you have to do under root of x component square plus y component square. No need to memorize this, but be thorough with the concept. How to find along x, how to find along y, and how to take the total value. Okay. Now, how do you find this angle alpha? Tan alpha. How will you find this opposite side? By adjacent side. What is opposite side here? What is the opposite side here? Can I say it is Vy and adjacent is Vx? This is the opposite side Vy and this is the adjacent side Vx. So it is Vy upon Vx. So just substitute the numerical data what you got, you will get the alpha value. And what is trajectory equation? Here we'll follow the same equation. What was that equation? Y is equals to x tan theta minus g x square by 2 u square cos square theta. But we'll do some modifications here. What modification we have to do here? Think once. This was the equation for a projectile from the ground with some angle theta. Now if you see this case, projectile from some height, is there any angle? Is the body projected with angle, or it was simply projected horizontally? From some height, that is fine, but how is it projected? It was projected horizontally. So where is the angle here? No angle, right? So theta is 0 here, angle of projection is 0. So just substitute this data. What is cos 0? Cos 0 is 1. And what is tan 0? This is 0. So what are you left with? Y is equals to just minus g x square by 2u square. This is the trajectory equation. I hope you are clear. Any difficulty? Please let me know. Please comment. Clear. So we'll see one PYQ based on this. A very easy PYQ which was asked in 2002. A particle A is dropped from a height. Okay, so there is a particle A. It was just dropped from certain height h. Let this be the height. It was just dropped. That means initial velocity is 0. 0 meter per second. Now particle B is projected in horizontal direction. That means the case which we have discussed now with a speed of 5 meter per second. So from certain height, from the ground, the particle B was projected horizontally. And with how much speed? 5 meter per second. From the same height. So here also height is same. Then the correct statement is. So if you see the options, they are asking which particle will reach first. Whether it's particle A or particle B or both, what? That means they are asking the time of two particles. You have to compare the time of two particles, like which is reaching first, second, in the sense they are comparing the time taken. Now, as I told you, we consider projectile from some height as a freely falling body, and time of fall is same in both the cases, right? So what will be the time here? If I take the time taken by A, that is also root 2h by g, freely falling body. And if I take the time taken by B, projectile from some height, that is also 2h by g, right? So which will remain same here? Time will remain the same. So what is the right statement? Both the particles will reach the ground simultaneously because their time is same. Clear? If you are thorough with the concept, no need of this explanation also. Directly you will catch the point. One is freely falling, the other is projectile from height. That means both will have the same time. So answer will be option C. Clear? So this is what for today. Just recollect what we have discussed in today's class. Everyone, just recollect what we have discussed. We have clearly understood the concept of trajectory. We have seen its two equations, and we have also covered projection from a height. And we did previous year questions to see how these concepts are actually tested in your exams, right? And in the next part, we will move to very important concept in 2D motion, that is relative velocity in 2D. We have discussed relative velocity in 1D, right? And in the next class, we will see relative velocity in 2D. This is very important because this concept will help you analyze the motion when multiple objects are moving simultaneously, which is again a very important topic for exams. So make sure you are comfortable with today's concepts. Practice the problems that are available at your end, and I will see you in the next session with this relative velocity topic. Okay, so have a nice day. Thank you so much.